Hello YouTube, welcome back to my channel. Today we are going to talk about sigma notation or summation notation, and that is expressions that look like this. This is a Greek S. Now this is an elementary Mathematica tutorial. I'm going to show you some Mathematica ways to talk about or calculate with sums, but I'm also going to introduce you to some elementary mathematics in this video. Okay, this is a very elementary tutorial and discussion of mathematics and summation notation in particular, but I'm going through this booklet, a YouTube course in Mathematica. Okay, it's very elementary. Again, if you're looking for something more advanced, try one of my other videos. Okay, I've got several more advanced videos. All right, let's get into it. So sigma notation, or otherwise known as summation notation. All right, so let's have a look. It is an abbreviated way of representing a sum, usually many numbers or variables, and it looks like this. So you have a starting place, an ending place, and then you have an expression, that thing which is to be added up. Okay, so this bottom one tells you what number to start with. And this at the top, this number, tells you where to stop. All right, so let's have a look at some examples. So on the left of this expression, we have the sum from j equals 2 to 5. All right, so that's j equals 2, j equals 3, j equals 4, and j equals 5. So that's 4 things to add up. Now here is the expression 3j plus 1. So what we do is we just supply in, to start with, j equals 2. All right, so we have 3 times 2 plus 1. And this is our first summand, that thing which is to be summed up. All right, next we include the next j term here, which will be j equals 3. All right, these are the whole numbers, positive whole numbers. Well, not necessarily positive, right? So you could start with the j equals minus 5, for example. So they're whole numbers that we're supplying in. All right, so we sub in j equals 3. 3 times 3 plus 1. So that's the next summand. We keep going. 4 and 5, and we stop at 5 because the top tells us to stop at 5. All right, and then you might want to simplify and add them up, and it comes out to be 46. All right, so let's open up a Mathematica window and do the same calculation. All right, now I'm going to first open up a palette because there's this symbol, the Greek S. It's an uppercase Greek S. All right, Basic Math Assistant. I've opened it up. I'm waiting for it. I'll move it to where you can see it. Now let's have a look. We see down here at the bottom, not quite the bottom right, but next to it, right here, there's the summation notation. I'm going to click it now. All right, and there we see appearing a spot to say what we want to sum over. All right, let's let it be j. All right, and then we'll say from j equals 2, and then we want to stop at 5. Okay, and let's put in, I'll put this in brackets. Let's see, 3 times j plus 1. Okay, here's our expression. If I press Shift Enter now, I should get 46. Let's see. Yep, 46. Okay, so it has done exactly this. Now let's just double check. 3 by 2 plus 1 plus, and I'm going to copy paste these to make it easier. See, there were 4 of them. Okay, the next one was 3, the next one was 4, and the next one was 5. All right, Shift Enter, we should get 46. Yes, indeed, we get 46. So that's what summation notation means. There's yet another way to enter this. If you didn't want to pull up the palette, well, you can just write sum with an uppercase S. You put in your expression, and then you say what you want to sum over. J goes from 1. No, it was 2, wasn't it? 2 to 5. Shift Enter, and again, 46. Okay, so that's summation notation. Now let's have a look at some of the properties. Now, the first property, it looks like we've got four main properties of sums. All right, the first property is that if we're summing over j, and we have a product where k is just a constant times j, we can factorize that out of the sum. Okay, so let's just look at this one and talk about what's going on here. Right, so look, I'll write it out longhand, all right? So this says, all right, left-hand side looks like this, k times 1, because we supply in 1 first, plus k times 2, plus k times 3, plus, and then it's common in maths, when you have a pattern, you can sometimes put dot, dot, dot. Okay, plus, now what is the last one? K times n, because n is the last number. Okay, now have a look. You can factorize the k out because it's common everywhere. So, right, I would have, now I'm going to write this not in Mathematica code, but I'm writing a comment here. So this is kind of a pseudo code here. All right, so I'm writing that I am factorizing out the k. And then what we have remaining once we factorize out the k is we have 1 plus 2 plus 3 plus dot, 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 plus the last one was n. All right, so just factorization, nothing special but factorization. Okay, now that I've done that, I can recognize what I have here in this bracket. That is a sum, right? It's the sum from j equals 1 to n of the j. Okay, so let's go and write another line that this is. And now look, I think I want to grab the summation notation, so I'll open up the palette again. Palette, Basic Math Assistant. All right, I'll look for the sum. Okay, and then we have j equals 1 to n, and that's just the j's. Okay, the whole numbers from 1 to n. All right, so we've proved this identity. Okay, so it's a consequence of the fact that you can factorize numbers out. Okay, so I said that was not code, that was just comment, so I'll turn that into a comment. All right, and let's move on to the next property. So I'll go into a new cell to talk about this. Okay, now look, it's not said here, but what I mean by this expression is if we have some function of j. For example, j squared plus 5, j cubed minus sine of j, etc. Some function of j. So what is it saying? It's saying that you can view this in a slightly different way, right? You can change your... Oh, that's weird. Google just spoke to me. Okay, anyway, so this says that you can change the starting point from j equals a. Sorry, j equals 1, you can change that into j equals a up to n plus a minus 1. But what you have to do is change this right here. Okay, this thing inside the function. Now let's look at that from a little bit of a different point of view. Okay, so I want to grab some summation notation. And again, I'm making a comment when I write this. All right, so we had... Yeah, so I'm just expressing that I'm looking at a function of j. Okay, now I'm adding those up. Now what does that mean? Let's write it out in long form. It means f of 1 plus f of 2 plus f of 3 plus, and then we keep going in this pattern, and then we would stop at n. Okay, so that's what that left-hand side refers to. Now let's stop there and have a look at the right-hand side. Okay, now what does the right-hand side say? so we have on the right hand side, copy, paste. All right, I think I need to scroll up just a little bit. All right, so now I'm entering what is on the right hand side, j minus a plus 1, and then we were to start with j equals a and finish with n plus a minus 1. Let's check this. All right, so we are meant to substitute in for j a first of all. All right, so a minus a plus 1. Okay, let's leave it like that for now. And then the next one, we sub in 1 more than a. All right, so this will be a plus 1. And then the next one after that will be a plus 2 for j. Okay, and then let's put a dot dot dot. Whoops, not plus plus plus, plus dot dot dot, and then plus. The last one is where we substitute in n plus a minus 1 for j. Okay, so n, I'll copy this, paste it in there. All right, so this is what the right hand side says. And now let's simplify all of this. So come to a new line so that my head is not in the way. All right, so we can simplify a number of things. So inside what we're to sub into the function, we can simplify those. All right, so a minus a is 0. So the first one is just f of 1. Okay, the one after that, there's another a minus a in there. So otherwise we have 1 plus 1 is 2. All right, so then there's f of 2. Okay, and then there's an f of 3. And then there was a dot dot dot. And then finally, let's look at this last one to simplify it. A minus a, so the a's vanish, the 1's vanish, and then what remains is n. So that's f of n. Okay, so now you can recognize what this is. This is exactly what was on the left-hand side. All right, in other words, we already found out that it was just this. Okay, so copy that, and I'll write equals this. Okay, now let's make that bigger so we can see what we've done. All right, so we have shown that, so this equals this, all right, which was the second property of summation. All right, now all of this is a comment, so I'll turn it into a comment and talk about the next property of sums. Okay, now the next one says that if you have, look, to tell you the truth, that's a little typo right there. I should have an I there, okay? I should have an I right here and right here. Okay, but it's also true for J, if it were J, but I meant to have an I there. Okay, so this says that you can break it up into two sums. If you have a sum of two functions, for example, I cubed cos I, something like that, okay? And I'm referring to I as the integers that we substitute in here. Okay, so you can break it up. Now what's going on there is that we have, so let's write again in comment form, I have f of I. I'm going to pretend that I did this correctly, and I'll put in an I for the input of G. All right, so, and I want a summation notation, so just open up the palette. Anyway, my computer's a little slow. I try that again. Oh no, it's in the wrong window. Okay, sure, here it is. So I wanted a summation around that. So you see how I've highlighted this? And if I just now press the sum button while it's highlighted, it should go in there. No, maybe I'm thinking of a previous version of Mathematica, like Mathematica 10. Okay, so I want j equals 1 to n, and then in here I want to put f I plus gi. Okay, so this is, now let's just write this in the long form, which is f1 plus g1, and then the next term will be f2 plus g2. And then we know the pattern, so let's just put the dot 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 right here. And then our last summand will be f of n plus g of n. Okay, so what is this result here saying? It's saying that we can view this first as a sum of the f and then add on the sum of the g. All right, so we can see this here because we have, so we have commutativity of addition, meaning I can move things around, move the order of these sums. All right, so first of all, let's take off the brackets. And then, hold on, so I'll just move them around as I'm saying. All right, so commutativity of addition, move that one to there, and then move, I need another dot dot dot, so plus dot 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 f n, and then remove it from this. Okay, and then I'll just put these on two different lines so we can really see what we have here. All right, so all I've done is move things around, all right, which you can do by commutativity of addition. Let's put a bracket around that to really emphasize that we want to think of this as two different things. All right, so now that we've done that, let's recognize that the first set of sums in brackets is a sum of the fi. Copy that, and then I want to come down and paste. All right, I'll leave a little gap so we can see this great. And then I want to copy this and say that this part is just the sum of the fi. All right, and now looks like too many brackets, so let's get rid of that set of brackets. And then the next one, you see, it's just the sum of the gi. Okay, so the gi. And then I'll put these together. All right, so let's see what we have. This equals this, and that's exactly this third property. All right, let's move on to our last property, which is a really easy one. Now, this last property says that if we're summing over I goes from 1 to n, and we're adding up the m, well, it's just m times n, where m is a constant. Let's have a look. So copy out a sum notation. All right, and then in here we have this constant m. All right, so let's write this in long form. So that says sub in j equals 1, okay? But the expression is just m, so the first one is m. All right, sub in j equals 2, but the expression is just m. All right, so that's plus m. Then j equals 3, well, it's just m plus dot dot dot, and the last one, sub in j equals n, well, it's just m, right? That's the expression. Now, how many of these do I have? All right, 1, 2, 3, dot dot dot. I have actually n of these m's. Okay, given that, well, I can count them up and say that that's simply m times n. Okay, m times n. And it's as easy as that. Okay, so these are the properties of summations. Now, one of the exercises you might one day be asked to do is to recognize a particular pattern as a sum. I'll give you one example. Now, this is the last thing I have to show you in this exercise, so let's just I'll pull up a palette again. I'll enter a fraction. Okay, I'll close the palette. Let's go 1/2. All right, plus. Let's see how we can change this. 2/3. Okay, what's another one? 2/3. Let's see, what do I want to put here? How about 3/4? 3/4. Next one, let's put 4/5. All right, by now you can see the pattern. All right, and then we can put a dot 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 plus. And then let's suppose we stop somewhere. Okay, so let's say plus dot dot dot. Okay, now you might be asked to recognize this and write it as a summation. All right, that's one of the many things that someone might ask you to do. So let's recognize this. So what do these all have in common? All right, so they're fractions. The numerator appears to be one less than the denominator. Okay, so for example, j over j plus 1. So let's just write j over j plus 1. Okay, but this is a sum, isn't it? So let's turn that into a sum. Copy this, put it right here. Okay, is that correct? Now what happens if we put in j equals 1? Well, we get 1 in the numerator and 1 plus 1 in the denominator. That's 1/2. So that's actually correct. Okay, so these two are in fact the same once I note that the end point is n over n plus 1. Okay, now it's much easier to look at an expression in summation notation and write it out in long form. Going the other way, like I've just done, is a little bit more of a challenge. Okay, now, one more thing. I said that was the last thing for the session, but one more thing. What if we instead chose j minus 1 over j? All right, how would that be different? Because we could do that, right? Okay, so let's try that. J, we said, the denominator should be j, the numerator should be j minus 1. Okay, how can we view it in that way? Well, where would we be starting? If we started with j equals 1, we get a 0 numerator, which would not match this. Okay, so in this case, we would have to start with j equals 2. All right, so let's copy this and say j equals 2. Put this in there. All right, but the top of this is not quite correct, is it? Where would we stop? We want to get an n in the numerator. Okay, so in order to do that, we would have to stop at n plus 1. Okay, so let's note that these are all the same. Okay, and I'll turn that into a comment because it was not code. All right. That's all for now. We've done summation notation. So in the next video, I should talk about fractions. All right. And here and there, I'll do some more advanced ones so that people interested in advanced things don't get bored. Okay, that's all for now. I'll see you next time. Bye.